For this video, we'll focus on what we call the maxima and minima of a quadratic model by this process completing the square. So the things that we care about so far that we've seen with the quadratic is we care about the initial height, how high off the ground is something initially. We care about the maximum height, how high does something get to its maximum, and this is what completing the square is going to help us with. We care about the distance traveled all the way down the field, and sometimes we care about the time of flight. How long is something flying through the air? How many seconds? 5 seconds, 6 seconds, whatever, 20 seconds. Now we've also seen a quadratic relationship can be modeled in two ways. We can see it in this analytic form, and we can see it in what we call vertex form. We kind of like vertex form because we can see the vertex basically sitting right in the equation. Now since both forms have value, we need to be able to switch between them. And this process called completing the square is going to allow us to switch from analytic form over into vertex form. So just a quick example here. Suppose I have a quadratic in analytic form. I'm going to plug in x equals 1. 1 squared, take away 14 times 1 plus 38. That's equal to 25. So I know that the coordinate 125 satisfies this equation. Okay, this is going to come up later in the video, so I just want to point that out. So 125 works in that equation. So here's the question. We're going to write this quadratic in this vertex form. A bracket x minus h squared plus k. So step 1, we are going to factor the first two coefficients. So here's my x squared and my takeaway 14x. The common factor is 1. Okay, I'm going to leave the x's in there. I'm just going to look at the numbers. I'm going to pull a 1 out front. Okay, there's my 1. And then when I factor it, here's a couple brackets. I know from common factoring, I have to put these two brackets down. Well, this is sort of the beginning of this structure, right? I have 1 bracket something. Well, there's my a bracket something. So I'm kind of starting moving towards that structure. Okay, step 2, this is probably the weirdest step. We add, then subtract the square of 1/2 the coefficient of x. So let me explain this one. So here's my coefficient of x, negative 14. What I do is I cut it in half, make it negative 7, and then I square it, and I make it 49. And what I then do is I take this 49 and I add it into my equation. And when I do that, what I've done is I've created this perfect square. I've created this trinomial that we can factor. So the process is called completing the square. They should almost call it creating a square. We're just kind of making this up. So we're just building this trinomial in the middle that we know we can factor. Now, when we do this, when we add this 49, we're not allowed to just, as you know, we're not allowed to just add a number to one side of the equation. So what we actually do is we add the 49, and then we also right beside it subtract the 49. Now that's a little weird because I know we're going plus 49 minus 49, that equals 0. So in effect, we're actually adding 0 to the equation. So we're allowed to do that. We're allowed to add 0. But we're just sort of breaking up into two parts. We're going to take the positive 49 part and include it in our thing we're going to factor, this trinomial. And we're going to take this negative 49 part and we're just going to attach it in with the 38 and we're still going to be in the equation, it's just not going to be sitting there. It's a tricky notation thing, and it's something I have to show you. This isn't something kids figure out on their own. This is a process you have to be shown. This is called completing the square, and this helps us convert from one form to the other. So the next step, step 3, is we're going to reduce the brackets to a trinomial. I want to be able to factor that trinomial, and I have this negative 49 sitting here. So what I do is I'm going to actually pull it out and write it outside of the bracket. And when I do that, I essentially have to unfactor it. I have to multiply it by whatever is sitting out front. Now in this case, it's actually a 1. So 1 times negative 49 is just negative 49. So that now, this negative 49 just sits outside the bracket. And now, inside the bracket, I have this trinomial that I can factor. So I'm going to factor the first 3 terms. Two numbers that add to negative 14 and multiply to 49. Of course, are negative 7 and negative 7. So I just do some simple basically trinomial factoring with that. And then since this is -7 times -7, that's -7 squared. And then I just combine the last two terms together, and that's it. I'm now in this form, this vertex form. So just to confirm, this number from this coordinate from the very beginning, 125, this works here too. If I put 1 in here, 1 take away 7, -6, squared is 36, times 1 is 36, take away 11 is 25. So this also gives us that same coordinate. It's the same equation. It's the same quadratic equation. It's just been rewritten in vertex form. And the advantage of this is that we can now, of course, see the vertex of that expression. Now, since sometimes we see the vertex, we're curious as to how the quadratic opens. The leading coefficient, and here this 1 is positive. So when the leading coefficient is positive, the parabola opens up. Okay, it's like it's smiling, it's like it's a happy quadratic. And then if the leading coefficient, if the number out front was negative, then I guess it's a sad quadratic, and it's frowning. Okay, we've seen lots of negatives. Those are all those gravity questions. Those are all the projectile questions. Every time we've kicked a soccer ball, it's been negative. That leading coefficient has been a negative sign. Well, we're starting to see this pop up again here. If it's positive, I know it opens up. My vertex is here. If it was negative, I know it opens down, and my vertex is up here. So let's try an example. So this would be complete the square on this trinomial, quadratic, x squared plus 8x plus 10. I common factor the first two. There's just a 1 as a common factor, so it's up front. I take my 8, I cut it in half, which is 4. Then I square my 4, which is 16. And then I add 16 and subtract 16. And this, I'll admit, this part's a little weird. That's an odd, it's an odd process. But I guess the good news is that it's the same process every time. Once I'm here, I know I'm going to take this -16 out of the bracket because I want to have just a trinomial left. When it comes out, I have to essentially unfactor it, and that's multiply it by the 1. In this case, it just stays -16. Now I have a trinomial, quadratic, I can factor two numbers that add to +8 and +16 are 4 and 4. And again, that's why this funny step, I know this step is odd, but what we're doing is we're creating this, essentially this perfect trinomial that allows us to factor it, that allows us to get it written in this form. So we're kind of rigging the question. We're kind of setting it up so it works. So it's a little bit of a funny step, I know. And like I said before, we can't just sort of add a 16 to this thing. That would change the expression. But if we add it and then subtract it, we're actually allowed to do that. We're allowed to add 0. So anyway, down here at the bottom, we have this in this vertex form. And then if I needed to know the vertex, it would be sitting just there. The vertex at -4 and -6. Okay, that's it.